Hello, and welcome to a new episode of AWS Tech Tales. I'm your host, Matt Burke.
And I'm your co-host, Samara Reaño. Welcome back, everyone.
Welcome, everybody. So, AWS Tech Tales, this is the show where we talk about real life customer issues, what you can do to solve them. We tell tales of all the problems that might go wrong in the cloud, and how to solve them live. And today, we are taking some time to troubleshoot, to fix, to approach new problems on EKS. So let us know in the chat if you're an EKS expert, if you're just getting started. Hey, Brigetti, welcome. Welcome to the show.
Welcome back.
Zamara, what's your experience with EKS?
I would say very limited. I have I guess I would say like a 200 level expertise on it. Haven't had to deal with like a specific issue to troubleshoot. So I'm looking forward to today's topic. I always learn a lot. I feel like a lot more in 1 hour than I would do reviewing documentation for 2 to 3 hours. So I'm very excited about that.
Oh, AWS with Tech Reformer says more ECS here. Well, next week we have the episode for you. We're going to be doing the same topic for ECS. And Sigama said, I dabbled in EKS. So this is a great episode for you today. So we have one for next week, one for this week. This is great.
Yeah, absolutely. And for those of you that are joining today and are going to stay tuned to Live Troubleshoot EKS, I think it's a perfect opportunity to remind our viewers of where they can find our future episodes. Like next week, where we're going to be talking about ECS.
Yeah, so we will drop it in the chat, but we have our community live stream page where you can check out all of our content, and we post pretty much every other week on the latest episodes, and if you miss any of the links, if you've got to tune out later in the stream, the rest of the recording will be there for you to check out. For me, and I don't know if anybody else out there is like this, I played around with containers a bit before Amazon. This is one of my weak subjects, actually. I'm not afraid to admit it. I do a lot on this show. We've troubleshot databases together in previous episodes. We troubleshot networking together in previous episodes. But this was a time when I said, I need to phone a friend. And I don't know if folks out there, if you've got somebody like that at work where they got an expertise in something that you're weak in, and you've got an expertise in something that they're weak in, and you kind of plug each other in. That's what this was like for me, because I said, hey, we could troubleshoot EKS, and then Samara and I would kind of just like bang our heads against the computer trying to figure it out. But we have a guest here that's going to help us today. We're going to say this is a moon topic for me. A moon topic. New topic?
Maybe he's referring to like it's just something new to him as well, that it's like so far away. So maybe that's what he means.
yeah. So that's the idea today, is that we're gonna need your help in the chat. So this is an episode where you can listen in, but at the same time, you can let us know what to do. Oh, moot. Yeah, that's probably a good Toyser. That's probably a good
moon so far. There you go. Thank you.
So we're going to go through with our guest, Mo, who's an esteemed TAM colleague of ours. So if you have a technical account manager out there, give them a shout. They are probably the most important resource you have from the support perspective. We're a little biased as TAMs ourselves, but
a little
biased. And we're going to come in, and he's got an environment ready for us to go. And we're just going to work through these problems together. And since Mo's been troubleshooting containers and Kubernetes even before his time at Amazon, he's going to come in and he's just going to talk through his methodology, and we're going to figure out what's broken here in our environment. So without further ado, we're going to bring in our guest, Mo, right now. Mo, welcome to Tech Tales.
Hey, thanks for having me. Appreciate it. By the way, this is actually my first time on Tech Tales episodes, so I'm very excited to be here and be part of the Amazon EKS troubleshooting session.
Oh, yeah. That's awesome, Mo. Thank you for joining us today. And can you just give an introduction of yourself, what you do here at AWS, any interests that you like, whatever you want to share with our audience?
Sure. Yeah, this is Mo. I'm a technical account manager at AWS based in Orange County, California. I'm also part of the containers technical field community at AWS.
Oh,
So
tell us
as
more
Matt,
about what a technical field community is.
so this is basically a program. It's a community where you have specialties, subject matter experts on a service. In this case, it's EKS and Amazon Kubernetes for containers.
That's awesome.
So yeah, as Matt said, just to give you a quick background about myself, before joining AWS, I do have a long career doing being a system engineer, network engineer. Then I transitioned at some point to DevOps engineering. And part of my role as a DevOps engineer was to administrate and maintain Kubernetes clusters on-prem and in the cloud. So all the fun stuff, not really, troubleshooting, finding problems, fixing those problems. So one thing to say I believe that going through those troubleshooting exercises and challenges really gives people a solid understanding on how systems work. Like different network stack, how components work, what they do, how they talk to each other, and the dependencies. Plus,
Oh,
you
Mo,
have
we have a
configuration.
question from the chat. I think it's a great question. Schizophrenic
Yeah,
web developer asks, "What is the difference between DevOps and systems engineer?"
that's a good question. So system engineers is basically building systems. You deal with hardware, operating systems at some point. DevOps engineering is really like a bridge between software and systems. So you have all the CI/CD pipelines, you develop that. I liked this DevOps engineering because I was able to use my networking skills, my system engineering skills, my software skills, QA, all that. So it's more involved, I feel, DevOps, and I think at some point it was the way to go, and that's my opinion. But yeah.
Wait, at some point, not anymore. Is it, or are you saying that just because now you're here at Amazon?
Yeah, I mean, I still miss the DevOps days, but the nice thing about technical account managers, we are empowered to do whatever we want, be technical, and I use a lot of my DevOps skills, and I'm able to do that. So I can
Cool.
relate to DevOps networking systems.
That-
So I love that.
I was gonna say, especially if you're in a technical community, you can definitely continue to develop your
Yes,
skills there and
exactly.
apply your knowledge. So
Yep.
So then I guess we're giving you a little bit of taste going back to the before times. Do you want to start to walk us through, tell us what
Yeah.
environment we're troubleshooting and what the first problem was going to be?
So in this session, we have different clusters, different problems, and I think we're going to focus on the troubleshooting mindset or the thought process on how to identify problems, how to fix them. One thing before we start, I want to mention observability is important in any system, the monitoring, whether it's traces, metrics. Specifically to what we'll be doing here, we're going to be looking at the Kubernetes logs. So it's important to identify the relevant logs, know where to find them, and how to access them. So let's jump in.
all right.
All right, I'm going to bring your
first problem.
screen right onto the stage. So talk us
Perfect.
through. Hey, Jeb,
Okay.
Jeb George, welcome.
So let's read the first problem. So this is a cluster. You see the cluster name and the region. So problem statement. Your team's first issue is encountered when you're trying to connect to the clusters. They are using kubectl client to connect to the clusters. However, they encounter the following error. You must be logged into the server. The server has asked for the client to provide credentials.
Okay.
So, folks, this is where we need your help. As you're seeing in the screen, this is not meant to be just show and tell. That you can at any time tell us where you want to go, what you want to see, and we'll try to help. And usually, as we know, we'll get people across the hour today that may not know what's going on. So we're going to put this helpful ticker on the bottom to let folks know what we're doing. So you can help us in the chat at any time. If you want to go to a different area, you have an idea of what might the problem be, you post it there. But until then, Mo, it's all up to you.
Yeah, and I'll be happy to provide some hints and wait for some feedback. But
we have one, Sigma Gamma 71. Check your kube config and make sure you follow docs to proper login.
That's great.
Cool. So if I do the kubectl command right now, let's say kubectl get nodes. And again, this is imagine a user doesn't have his environment set up or her. So from this error, it's obvious that I don't have the kube config set up. And I can tell because I don't have a kube config file here. So the first thing to do, and of course, I do have my AWS credentials set up already.
That's great because someone brought this up. Is your IAM user in the kube config right or IAM role? So they are right on top of it today, everyone. Thank you.
Yes, I like that.
Yeah,
So
authentication issue.
Yes. So when we tackle issues like this, two things to think about: authentications and authorizations. So first, let's create our kube config. So this kube config is created now, and you can be seeing it here. But still, let's run the kubectl command and see what we get now. Oops.
Error. Uh-oh.
So the error says, could not get in current server API. Server asked client to provide credentials. You must be logged in. So sounds like an authorization issue.
And that's what people have been saying in the chat, authentication issue.
Okay. So let me...
How do you fix that?
Right. So let me quickly go through some concepts. When we run the kubectl command, what happened is a token gets generated through the AWS CLI get token. This token gets passed to the API server, the Kubernetes API server. The API server then, because the native way we're using the webhook token authentication, so this token gets passed to a webhook. And then this webhook will see that there is a pre-signed URL in this token, which leads to STS. So it will contact STS. There's some talk back and forth. This token gets verified by STS. If everything checks out, the information about the users will be sent back to the API server. So now the API server says, okay, this user is good, and I know the IAM principal. So that's good. Now, the other thing is authorization. So now the Kubernetes API server needs to see if this principal has the right access or policies to be able to access resources in Kubernetes. And from this error, sounds like it's not. So my IAM principal, and I have it saved in an environment variable, and I can show that it's this role, WS ops role. Now, one thing to check, if we go to the AWS console, and by the way, during this session, I'm going to be using a combination of AWS console, kubectl, and also K9. We'll talk about this in a little bit. I feel like it's more powerful to show all that, and I'll try to show visualization as much as I can when I can. So if you go to this cluster that we're troubleshooting, and if we go to the Access tab, we know that there's two ways of authorization. The old way is the config map, and the new way is called IAM access entries through the EKS API. So what this does, we create mapping between an IAM principal and a Kubernetes role. And this is how this principal can access resources on a Kubernetes cluster. So if you look in this case, my role is not in the access entries. And I can tell you it's not in the config map.
So then my question is, when Kunguro from Hell said your IAM user is in the kube config, right? So technically it was in there, but I think they were on the right track here.
So if you look at the kube config file, actually, let me pull that. That's a good question. It doesn't have the principal. So we're using the console credentials to run the kubectl command. It accesses the kube config, and what it does, it runs a get token. It's a CLI, and it gets token. That's all that happens. And this gets passed, as I said, to the API server. It gets authenticated with STS, but then you need to have the authorization piece, and this is what's missing. So you still need to bind those principles to a role in Kubernetes. And this doesn't happen in the kube config file. So if I was to go to the kube config,
and Kunguro from Hell says, yes, I wanted to check this file first.
Yes,
so your wish is our command.
So let's check this file. You know, it has the information about the API server. And if you look, this is the important part here, the users, right? So you'll see that what's happening every time I run the kubectl command, it's actually calling the get token CLI command, right? And this is how you're getting this token that is really needed for this handshake between API server and STS. So this is one step of the puzzle. The second step is telling Kubernetes that, hey, as this IAM principal, you need to be allowed, right? Make sense?
Yeah, let's fix it.
Yeah, it
Okay,
makes sense. I guess my only question, Mel, right? This is the same user that has access to the console and is able to see within the cluster itself, but it's the same user that cannot actually be able to do an action within the cluster itself.
100%.
Interesting.
If you look at actually my top right screen, you'll see that this is the role, the same role that I'm using
the exact
to access
same
the
role.
console. Yeah.
Okay.
So 2 questions that we've got from the chat. One saying, this has nothing to do with IAM role, right? Only Kubernetes objects, correct?
So again, what we're doing here is doing the mapping between an IAM role, because it's the IAM principal in this case. It's the one trying to access through kubectl the Kubernetes cluster, and mapping it to a role that Kubernetes understand. So in Kubernetes, you have roles and you have cluster roles, basically roles to the entire cluster, or you have roles that is specific to a namespace. But you need to have this association to kind of allow this role to access the Kubernetes resources. So
while you're doing that, I have a second question I'll answer while you're fixing the problem, which is
go ahead.
AWS with Tech Reformer says, off subject, can someone tell me how you're doing multiple hosts live from different locations? Oh, this is the same as when your Teams, your Zoom, we're all just in a virtual room
in a virtual
right now.
environment, yes.
Yeah. nothing too fancy.
Okay, so watch the command that I just ran. It's basically, I can do it, by the way, through the console. I'm just going to do it here because it's easier. So first, I'm going to create this access entry, and let's see what that does.
Okay.
So I'm going to go back to the console because it's easier to see things here. And I'm going to refresh my screen. And voila, I have
and
my...
Now you have the role. Okay.
Yes, but is that enough? Because look at the access policies. We don't have one yet.
You don't have one. Yeah.
So because I'm special, I'm going to give myself the admin. Let's say I'm the admin for this cluster.
Okay.
So I'm going to add this access policy tied to the IAM role. So let's refresh. So now this role has Amazon EKS cluster admin policy. And if I dig in and see what that is, it's basically policy that allows you to do admin stuff on Kubernetes. So let's see now if I can access.
Okay.
Kubectl get nodes, and I can see the nodes. Nice.
No more errors.
Nice. So problem 1 is complete, folks. Is we had issues lagging in, and so what was the solution to this issue, Mo?
So again, you need to think about this problem: authentication authorization. Is the kubeconfig file missing? First, of course, you need to have the right AWS credentials, create the kubeconfig, and then after you do that, you need to make sure in Kubernetes you have the right access entries, IAM access entries, or an entry needs to exist in the AWS auth config. Now, I'm going to go to this other tab, and I'm going to launch K9S. And K9S, by the way, is a terminal UI. It's basically what kubectl is doing, but it gives you this visual presentation, and it's easier to see logs, and you can interact with Kubernetes through this. So it's easier for the audience to see what's happening. Now, I'm able to access the cluster. Ignore those errors because that's problem number 2, but I just wanted to show you that now I can go to the nodes. I can go to the config map and other resources. So I have admin permission that can access anything on this cluster.
Okay.
Folks, let us know in the chat. Have you ever seen this before? Have you used K9S before? I'm interested to know if folks, this is when Mo showed this to me, this was my first time ever seeing it, and it looks very cyberpunk.
Yes, I was going to say the same thing. Count me in as the first one to drop the comment that it's the first time that I have seen this, and it's actually pretty cool.
Yeah, that's I cannot live without this tool when I'm troubleshooting issues. I mean, again,
There you
it's
go.
using different tools, but yeah, this one really helps you get the job done quicker
Okay, so
when
tell
it
us.
comes to troubleshooting. Yeah.
Yeah, so now that we've solved the first problem, someone has another recommendation. Mega Rotato said, I like Norton Commander for Kubernetes. I
Okay.
didn't even know Norton still existed. I think of like Norton Antivirus, you know?
I was gonna say that's the one thing that popped into my mind when I saw that.
Yeah, so Mo, what's next? We fixed one problem.
Let's go to the next one.
Now
So
what
we're
do we
still
have?
on the same cluster.
Okay.
And I skipped it. Okay, cluster problem 2. You have now successfully connected to EKS. Good job with
Okay.
your role and provided access for your team to connect. When you log into the cluster and check the node status, you found that the nodes are in not ready state.
Meanwhile, we have one person that's going to grab K9S, and Mega Rotato is just messing with us. Apparently, that's not a real thing. So you can also see that we're actually very gullible here on Tech Tales. This is why we have we don't know this topic as well as we would normally.
So I'm going to go to the nodes, and this is what the problem is talking about. If you look at those nodes.
Okay.
Not ready.
Not ready, both of them. Okay.
Yeah, it happened that this is a self-managed node group, but they're not ready. So the first thing I would do is check the logs, right? I can check the logs, or I can, in this case, do a describe command. So this is the nice thing about K9. Instead of me typing kubectl describe, I can just say, hey, with the D, and I can just describe everything. So let's go and check.
Yeah, folks, let us know what you think the problem is. These are in not ready state. What could it be? I don't have guesses. I don't know.
Okay, the problem is there. It says on the describe. If you look at, there's no line numbers, unfortunately, but if you look here, it says kubelet not ready, and then message container runtime not ready, network ready equal false, CNI plugin not initialized. So many things here, right?
I would say don't highlight it because it's better if you don't highlight it.
Yeah, when you highlight it, actually, we can't see what it says.
Okay.
Yeah.
Okay.
Kangaroo from Health said that it could be missing an ENI. Rotato said. They said I think it could be certificates are not well.
So yeah, missing CNI, that's a good point. This is actually, so again, we have so many things here, right? It says first, node's not ready. Then here we see that kubelet not ready. And then kubelet is saying, oh, well, because of CNI not ready. So one important things to understand here is there need to be some understanding on how the different components of Kubernetes works.
I was going to say, is this the case of another kind of like component and how everything flows?
Yes,
to be
exactly.
the problem? Okay.
Yeah. So it's important to understand that kubelet is a key component in Kubernetes. It ensures that pods actually run, containers run properly on the worker nodes. So it manages containers, and this kubelet runs as a process on each worker node. So one of its responsibility is, as I mentioned, managing containers, communicating with the API server, the control plane. It gets requests from the control plane, and it executes those on the worker nodes. It also registers nodes. So we know that the kubelet is not ready. So that's a big problem.
Yeah, we've got a few guesses in the chat now.
Yeah. Yep. We have one says missing or misconfigured CNI configurations is their guess.
So they're on.
Yes. Oh, wait, I got a couple more. Hold on, before you. I got authentication issues as one guess, and then I have a potential solution from one of our viewers: enable worker auto recovery.
Right. So here's the thing. So they're on the right path. Kubelet does need the AWS VPC CNI, which is the AWS implementation of the Kubernetes CNI. It actually invokes the CNI binary. And again, VPC CNI is responsible for pod communication. It also gets IPs from the VPCs and assigns them to network interfaces. So it sounds like VPC CNI. So what would be the next logical step to do is for me to go and look at my AWS VPC CNI, which does run as a daemon set on the Kubernetes cluster. So if I look here, you see other pods pending because kubelet is not ready. But this is the interesting part here. AWS-node, that's actually the VPC CNI pods. And again, these run as daemon sets. Daemon sets means there's a pod running on each worker node. So the first thing that would do here is go try to look at the logs. So if I look at the logs, but you also have a hint here, if you look at the status, it says image pull back off. So let's look at the logs.
Do folks know what that mean? Oh, so kind of we're saying add on VPC CNI to EKS cluster. So it seems like they're getting close to it.
Yeah, so the CNI is there, but it's degraded.
Oh,
see, so there's a
Okay.
problem.
Uh-huh.
Right? So let's go back here, but there is here. Let's do a describe and go down. So you'll see here that the kubelet backup pulling image. This is the CNI image. You know, when the pod launch, there's an image. It tries to pull it from Amazon ECR. The
which
elastic
Mega
container.
Rotato saying is the issue that they can't reach ECR.
ECR, right.
Good point. So the thought process now going back. So we know that what could be the issue? Either the image is not correct, or there's some permission issues where the worker node EKA, meaning that the VPC cannot access, not allowed access to ECR, or it could be networking. 3 of those. But I know that the image is correct because if I go here, this looks good to me. So let's look at why would be a networking issue. So to understand that, first we need to know where those worker nodes are running. Are they running in a private subnet? Are they running in a public subnet? And how do they access ECR, which is a public service? So for a worker node or an instance to access AWS ECR, you either need to go through an ad gateway, and if it's in a private subnet, then you need to have the right VPC endpoints. So let's go and look at the instances or the worker nodes that those pods are running on. So if I go back to the compute and those are not ready, I'm going to click on one of those.
And so a bunch of folks are saying, Kangaroo from Hell saying, oh, is this an internet gateway issue?
Yes. So let's find out. We'll find out right now. So this is my instance. If I look at the networking part and I look at its subnet, so this is a question for everyone. And look at the route table. So what does this route table entries tell you about those instances? Do they sit
It's small. You're gonna have to make it bigger for us to see.
Oh, sorry. Is it better now?
Slightly. So we have the local route, and then what's that destination? What
yeah, so this is an VPC endpoint. It's a gateway endpoint.
Oh yeah, I see. So you basically just have a route to the local. You can't go anywhere else, and you have your VPC
there's no
endpoint.
NAT gateway.
Yeah.
Okay.
But
So that's why you can't connect.
Is the endpoint the endpoint connecting to the EKS or something else?
Yeah. So this is a route, right, configured here, so that enables this instance, which is in a private subnet, to connect to S3, which is a public service, right?
Yeah.
But what else do we need? We need to connect to ECR, right?
ECR, right. That's why you're failing at the connection.
We need to have the VPC endpoints for ECR, right? Created. So let's see if these are created or not. So I'm going to go to and list all the VPC endpoints that are created in the subnet of those worker nodes. And I'm going to see a list. So.
And while you're doing that, I'm going to, sorry, I'm just going to pull up some of these comments. Because I think that based on what you're saying, you correct me if I'm wrong, Mega Rotato got the prize here. But I like what other folks are saying about it. Maybe you need your VPC peering connection. If this endpoint was in another VPC, maybe you would. And I like Visorin's comment here, which this I see happens a lot. I'm sure you've seen it happen a lot, Mo, which is that you're running out of IP addresses. Though I don't think you'd get the same error, right?
Yeah, true. So this is, well, whoever said cannot connect to ECR is the correct answer. So one thing to understand is if you don't have a NAT gateway, so if your worker nodes don't have internet access, not through IGW, internet gateway, or NAT gateway, then you need to have those private or VPC endpoints created. So we require a VPC endpoint for EC2, for S3, for STS, and for ECR.
Okay.
And for ECR, you need actually two, one for authentication and one for you to be able to pull the images from ECR. So now
because you need S3 access, right? Is that what you're saying that? So you need one for ECR and then for control plane.
Yes.
And then one for S3 to actually data.
Yes, because the images reside on S3.
Yes. So the activity is life.
Yeah.
Yes. So this is why this problem is fun, because it's really involved. Now, if I look at my endpoints, you see gateway endpoint for S3. I see two interface endpoints for ECR. And one of them is for actually ECR.API and ECR.DKR. And these are for authentication and pulling images. So wait a second, I have my endpoints created. So why the heck it's not working? This is where it becomes more interesting.
Well, okay, let us know in the chat. So we have the endpoints. They exist in the VPC. Why are we still not able to do them?
So everything, yeah. So
I'm over here thinking, yay, we figure it out. It's like, no, they're already there. So what?
Okay, one hint. When you create a VPC endpoint, what does it have? There's a policy. Because when you create a VPC endpoint, you can restrict what principal can access this endpoint. So if you look at the gateway endpoint, it has allow principal star. So it's allowing everyone. So perfect. Now let's go and look at what we suspect. It's ECR, right? So if I look at the ECR one, let's see one responsible for authentication. It also have star. Okay. So let's look at the other one that is responsible for pulling images. And I'm going to try to make this one bigger. Sorry, I clicked on the wrong one.
I was going to say, well, that one also has every... I'm invested now.
Yeah, and the chat's going wild. They're going, okay, it's not in your subnet route. Kendra is saying you have to attach it to the VPC by putting in the route table, of course. Nice.
Okay, I see a deny.
Oh, so everyone thinks it's just not in the route table, but there's a deny here in this.
Okay, so that's a good point. So here's the one explanation. When you route table, only gateway endpoints go in the route table. So S3, it was configured as a gateway endpoint.
Oh,
so
because we're automatically, because it's in the same subnet.
Yes.
The endpoint's already in the local DNS. So it doesn't have to be in the route table, right?
So correct. So when you create interface, let me correct myself. When you create interface VPC endpoints, you do not create route table entries. You just create them as long as in the same subnet. And the only way you restrict is through creating those policies. If you create a gateway VPC endpoints, you need to configure it in the route table.
But you could, like, let's say you had a more complex environment and it was like a centralized VPC where everyone's flowing in their endpoints. Like you can then you need to set in the route table the route to the endpoint in a different VPC, but because this is all local, you don't need to with an interface endpoint. I'm just right.
Yeah, no, interface endpoints do not get set in route tables.
Okay.
Only gateway endpoints. That's what I'm saying. So interface endpoints, you just create them in the same subnet and you can access them. Yep, definitely don't work. And okay, so if you look at the policy, we are denying this interface endpoint. By the way, if you look at endpoint type, it says here interface. We are denying batch
get image
download to this ECR repo.
Okay.
So to fix that, just for simplicity, I'm just gonna modify this one and I'm gonna give it the default behavior, which is full access.
But don't do this at home, kids.
Be very careful.
Joshua Huff said, did they unplug it and plug it back in? I feel like we're doing that right now with the config.
Okay, so now what happens, I updated, but twice not. It takes a few minutes to pull the image. So to speed it up, I'm going to do a rollout restart, restart the daemon set. I can do it from kubectl command, but because I have K9, I'm gonna go to the daemon set here and I'm gonna restart AWS node, which is the VPC CNI daemon set. So restart. Okay, let's see what happens.
Okay, so you still have another error. Is that the top two, right? AWS nodes?
Yes, so let me see here what happened. Did I save it or not?
Another question.
Let's see. Yeah.
How is the performance of VPC endpoints monitored to troubleshoot high latency issues encountering EKS? This is an intense question. And you can check in CloudWatch. There's a bunch of metrics you can use to monitor a VPC endpoint, just to see how much traffic is going through it.
That's right.
So
let me check here the policies. Just a second. I think I might. Oh, here we go. It took some time.
Okay, it was just refreshing. Okay.
This is always how it goes here when you're doing this stuff live.
Zamora was like pushing me to get it fixed.
I'm invested here, Mo. I'm like, no, let's see what's going on.
Okay, so I was like, wait a second. I gave it full access. So
that one just needed patience.
Now notice what happens here. The nodes are ready.
Okay. All right.
So again, to summarize.
Right. I was going to say to summarize.
Yeah, node's not ready because it's kubelet. Kubelet is a core component that manages containers, pods that runs on worker nodes, and it requires VPC CNI. If VPC CNI has a problem, then kubelet will not be ready. And in this case, VPC CNI was not able to download images from ECR.
Mm-hmm.
The pods were not able, to download images from ECR because we had a policy restricted the interface VPC endpoint.
So we spent a lot. Actually, well, it's interesting. The first couple of problems that we had are a lot about restrictions on security. Mm-hmm. So become really good friends with your ISO organization if you're not already, is what I'm hearing on all of this.
Yep.
So we've got about I wanted to reset for folks that may be tuning in that are new. So we've got about a little less than 20 minutes. We spent the most of the time troubleshooting 2 different problems with Mo here on EKS. Tamara, you want to walk us through what those problems are?
Oh, geez, don't put me on the spot. I'm still reading from this one.
Okay, I'll do it. I just wanted to share the limelight. So we talked about, we had some access issues. We were able to run some commands on the CLI, but we weren't actually able to access the underlying pods. So we fixed that. And then we also weren't able to pull the image for our nodes, and we will fix that as well via policy on the VPC interface endpoint. Is that a good summary, Mo?
Yep.
All right, let's keep trucking.
Okay, problem 3. This one is interesting. So this is a different cluster.
Okay.
And let's go through the problem statement. Your team recently launched a cluster with 2 node groups, with 1 node group each, and created 2 pods in default namespace. Your team requires to connect to internal Kubernetes services and external services. Upon testing, it was noticed that pod 2 has connectivity issues with connecting to the kubernetes.default.svc, which is the internal, and cannot connect to external domains without, and can connect to external domains without any issue.
Okay.
So
the internal one, it's not connecting, but the external one, it's working.
And also, it's only for pod 2. So pod 1 seems that it's fine to connect to everything, which makes it more like, what's going on here?
So we have a few, I feel like, containers experts in the chat, some that are more familiar with ECS than EKS, but let us know what you think the problem could be, or where you should start. What Tamara?
Like, for me, how my brain works, it's like, well, if pod 1 it's working and pod 2 is not working, I'm gonna go see what pod 1 is doing, how it's configured, and then I'm gonna do this and make sure that I isolate what the gap is between the two to isolate the problem. That's what I would do.
Mo, is she on the right track? I don't know. I mean that sincerely. I haven't looked at what I haven't skipped ahead or cheated at all.
Either have I. I'm just going by what I would do.
So I was distracted setting up the new environment because this is a new cluster. I'm just making sure that I can connect to it. I just set up the context. So I updated the kubeconfig, basically. That's what I did. Let's see here. Everything will appear that is running, right? So it's a DNS issue. And we know that it's actually pod number 2 is having this issue accessing the internal domain. External domain is fine. So,
and we have a comment that says it's probably the network policy in pod 1. I mean, so pod 1's working. So do we think
the
that
pod 1 doesn't have a problem? Yes, it's pod 2, the one that we need to see what's going on.
So let's go to each pod. This is how, again, going back to the thought process, I would like to go to pod 1 and then pod 2 and see what's different on a pod level, right? And then I'll take it from there. But one thing here, if pod 1 is running, it kind of tells me that the core DNS is fine. So maybe something specific to the pod 2, right? Or maybe the instance that this pod 2 is running on. So let's go to services. I wanted to show one thing here.
Okay.
And we have another comment. It could be the pod's DNS configuration. Is that
yes?
A good
So
guess?
that is correct, actually. Thank you.
We're just giving up the ghost already. Okay.
Okay. So in Kubernetes, Amazon EKS, the core DNS, which you're looking at here, runs as a service, and you can see the cluster IP for this core DNS is 10.100.0.10. Okay, so remember this cluster IP.
Wait,
now,
is this for both of the pods, or just for?
This is the core DNS service cluster IP.
Okay.
That runs on the cluster. So we know. I'm expecting that this core DNS server doesn't have an issue because pod 1 is fine, right?
It's fine. It's working. Okay,
but
got you.
I wanted to record its cluster IP and go back and do an exec, access the pod 2 and see what's its DNS configuration. So that's, again, this is what I would look first. So if I was to go back to my terminal, right, and I'm going to run this command, and I'm going to do it on pod 1, which doesn't have a problem. Okay. So let's do that. Sorry, just a second. Yes. Okay, so now I'm on pod 1. Okay, so if you're a Linux user, you'll know that DNS configurations are configured here. So what is the DNS configured here for pod 1? 10.100.0.10, which is the correct, right?
It matches.
It matches.
Yes.
So maybe if I go to 2, now I'm going to go to pod 2 and see what the resolve.config is. So I'm going to go do the same.
Okay.
Uh-oh, what do you see here?
Different. There are some zeros missing there.
No, yeah, well, it's 1.1.1.1. So it's an incorrect DNS.
But how did you know? Oh, because you have the 10.100.0.10. So we have some folks in the comments going, I was going to check the Etsy host on node 2, but not the pod 2. Mega Rotato said it's always DNS. That's funny because we've had comments in the past. It's always the network, but yes, it can always be DNS. Yeah, 1.1. Have you ever used Mo? I used to use 8.8.8.8 all the time when I was testing. Did you ever use it before? The Google namespace?
Oh yeah, that's like on your local machines.
Yeah.
We have another comment that says missing name server.
So actually in this case,
well, not missing. It's there. It's just wrong.
So yeah, it's pointing to 1.1.1. So it's gonna fail to resolve internal queries, right? But it still can go through the NAT gateway. This pod, if I was to do a NS lookup, google.com, it will be fine. Okay. There's no NS lookup command. Actually, I can.
Don't you just hate when that happens?
You just have to trust them.
Yeah. So the point here is it's an internal issue. Now, here's again going back to troubleshooting mindset. How did this 1.1.1.1 get configured on this pod? It's either maybe we kind of hard coded it in the pod template, maybe, or the deployment, or it's coming from the worker node, which runs kubelet. So it's important to understand now that kubelet, which runs on each worker node, is responsible for setting up the core DNS for each pod. So this etc resolve.config, actually it was configured by kubelet, which runs on the worker node. So if there is no more suggestions on what to look at, I would want to see if there is any hard-coded DNS in the pod. So if I go to the pods and look at, gonna make it easier here, go to the default one. So if I go here and I check my pod.
One question, this is pod 2. Yeah. We're looking at the configuration of pod 2.
Yes, correct.
Okay.
This is pod 2.
Right.
So I'm trying to see if there's any hard-coded DNS entry here that points me to 1.1.1, but there's nothing.
I have a bunch of comments actually piling in. This is a very popular. Thanks everyone for tuning in. I'm really excited. So I have they were laughing at you when you couldn't do NS lookups. Like container life equals no utilities. They said you did it on purpose. Borghetti chimed in.
No, I'm so used to NS lookup.
yeah, you forget. I have to I have to do my little thing over the comments. And then we have a good question, which is why do you know why it's called K9S instead of K8? Because Mega Rotato thinks that because dogs.
Yeah, I guess they came up with K8s and then they increased the one digit, like one number, 9, K9. I don't know for the tool.
And then maybe we can make K10 one day.
Yeah.
There you go.
Hey Sam, welcome to the chat.
Hello.
Sorry to interrupt.
So I already gave a hint, by the way, to look at kubelet, right? So because it's not in the pod, and we know that this core DNS is not a problem because the pod one is fine. So now we need to look at kubelet. How was kubelet configured on this second managed node group that pod 2 runs on, right? Okay. So to do that, let's run a command. And I'm going to show you also how to do it from the screen. So really what we need to do right now is find the user data. And I'm going to explain that in a little bit what that means. I'm going to exit from here. And don't worry, I'm going to explain what I'm doing here in a second.
And GM Llama is saying, hopefully all your definitions or your config files are in a repo. So you can just grep or search for 1.1.1 in one place quickly. And they're like, please let it all be one place.
Okay, so I pulled the user data.
Okay.
So let's take one step back. When you create a managed node group in Amazon EKS, when you create the managed node groups, you basically ends up creating an auto-scaling group. This auto-scaling group has a launch template, and this is where you configure those worker nodes. And part of this launch template, there's a user data where you can configure this instance as it comes up. It's kind of like the bootstrapping stage, right? And this is where you configure kubelet. So as the instance is launching, you configure kubelet to run as a process, and you pass certain configuration to kubelet. And as I said before, kubelet is responsible for setting up DNS on the pods. Now, if you look at what I did here, I extracted the user data of this instance that has this problematic pod 2. So if you look here, you see the bootstrap, kubelet, and
DNS cluster 1.1.1.
So this was intentionally hard-coded to use DNS 1.1.1.1. And this is why the pod 2 got this DNS. Make sense?
So if I understand this correctly, this is part of whenever the auto-scaling is taking place? Okay.
When the worker nodes are provisioned, right? And they get configured with kubelet, and depending on what we specify in the user data, this is what they get configured with. So to kind of make it easier for everyone, I'm going to go quickly to the cluster. This is the cluster 2. I'm going to go to compute.
Okay.
And this is going to be, just a second. So this is running on the .129.
.129.
Yep, which is this one.
Mm-hmm.
So I'm gonna go to the instance, which again got bootstrapped when it was launching, and because of the launch template. So this here, it's part of this auto scaling group, compute cluster ASG that you see here. So I'm gonna go to this auto scaling group, and I'm gonna look at the launch template. And inside the launch template, there should be a user data section under advanced details. If you look at that, this launch template, again, it's exactly what I did through the CLI. I extracted that. I'm just showing it right now via AWS console. So you'll see what the issue is here.
And
so
then
now
you
how
can
to fix.
also, oh, I was gonna say, then you can also go to CloudTrail and find out who did this.
Yeah.
I was going to say, this is something that a user explicitly like wanted to happen. It's not something that
Yes.
just automatically happens unless you specify that you don't want it to happen. Okay.
So in this problem, we had two managed node groups. One managed node group does not have this hard coding. So that's why pod 1 was launched using this first managed node group. It's fine.
Okay.
But then this pod 2 was launched using this other
This a
managed node
specific
group,
one. Yes.
which uses this hard-coded DNS. So I just wanted to kind of demonstrate, again, the whole idea of troubleshooting a problem, where to look. Then the last question is like, okay, how do we fix that? Any suggestions?
How to fix it?
Well, we have some comments saying, so the lesson is, please do not let your team perform weird overrides in user data. And they're saying
Another
we
one
roll
is
back.
roll back.
Oh.
Yes.
So to fix it, we cannot roll back. We're going to create another launch template, another version of the launch template, and assign it to the auto scaling group. Then what we're going to do is we're going to do an instance refresh on the ASG. So what that will do, it will kill the old worker node, and it will create a new one with the correct configuration, which does not have this hard coding.
Okay.
Does that make sense?
I think that a lot of the listeners were kind of going through that template and refreshing path. So I think that everyone is on the right path here.
Perfect.
So show us how to do that.
So I'm gonna do it through the console because it's easy to see it. So
sounds good.
First thing, this is the launch template. It's default 1 version 1. I'm gonna go modify template.
Okay.
I'm just gonna call it v2. I'm gonna go down, scroll down to the very end, and advanced details. And I'm gonna remove the -- DNS.
Okay.
I'm gonna create template version.
Oh, so you don't even have to kind of put anything in its place. It's just taking away that specification. Okay.
Exactly. Because if you do that, it will use the default Kubernetes DNS, which is the 10.100. Okay, so go back here. So now let's go back to the auto scaling group, which is this one. So this one is still pointing to the old launch template, right? So what we need to do here, if you look at the version, still default. So I'm gonna delete the latest, and I'm gonna do update.
Okay.
So now my ASG is pointing to the latest template. Now the last thing I need to do is
the question they're saying is this will only affect the EC2 instance which uses the different user data, right? Oh, they already got it. Yeah.
Yeah. So this will only affect the instances that are part of this ASG, which is mapped to this problematic managed node. So what we did right now will fix everything. So any future worker nodes or instances will be launched properly. So instance refresh. We're gonna go back.
How long typically does it take for once you fix the configuration and everything is as it should be, and you're doing the instance refresh? Is that kind of like take some time to refresh, or it's something that happens like automatically?
Yeah, I mean, it takes time for it to provision a new ASG, a new instance, and delete the old one.
Okay.
So Mo, we've only got a couple minutes left. Is there anything else that you wanted to show us to wrap up the demo portion before we start to wrap up the whole episode?
Yeah, start instance refresh here. I'm just gonna tell it to launch before terminating, and I'm just gonna go start instance refresh. And if you look at activity, you're gonna start seeing that it's already gonna launch a new instance. And very soon here, if we go back to K9, you're going to see that a new node pops up, and then it will terminate the old one. But the most important thing, this pod 2 will get rescheduled to start on this new provisioned worker node that does not have a problem.
Yeah, so Sam was saying, so basically this would be the way to do it with minimum disruption, right? Is that fair? Or is there something else you could do to make this more of like a blue-green deployment, I guess?
Yeah, I mean, another option, you can also create a managed node group, right? Without a problem, or you can point the pod 2 to the good managed node group. So there's different ways to do that. But yeah, I would have created a new managed node group and just get rid of the old one. It's kind of like a blue-green. And what I did here, I just fixed the existing work node. But it does launch an instance first, and it will move the pod to this new instance, and then it will terminate the old instance. So there shouldn't be any disruption.
Great. Well,
and by the way, it's already provisioned, and the pods looks like got rescheduled. And yeah, if I was to go back here and go here, I should see the new pod, hopefully. It's still getting scheduled. Let me see here.
That's okay. I mean,
that's okay. That's fine.
Yeah, we've got more than enough. I think we've proven the point.
Yes, we have some viewers say makes sense. Thanks, Mo. We have another one saying thanks a lot, guys. Very instructive and quite nice insights. So thank you so much for joining us today, Mo. This has been like extremely fascinating for me. I had never troubleshooted with EKS before, and you have opened a whole new world for me. So thank you.
Thanks, appreciate it.
So guys, thanks so much. We had so many folks tuning in. Thank you for all your comments. Thank you for helping us troubleshoot. We've gone through 3 different issues today. If you tuned in late, feel free to, we'll post this on YouTube recordings. We'll have it in the show notes next week. But before we go off, I just want to say that Mo is coming back next week.
Yes.
Like, thank you, Mo, for offering to do 2 episodes back to back. So a lot of you said in the chat, you said, I'm not that familiar with EKS, but I am super familiar with ECS. So we are going to test that knowledge next week. We're going to do the same thing, give you a broken environment. Mo's going to help us troubleshoot. So please come right back at 5 Eastern, 2 Pacific next week. And we'll see you there. So thanks everybody for joining us. And I'm really happy with the way this turned out. So thank you, Mo.
Thank you, everyone. And thank you all for participating.